Hello, in this video I'll be doing the demo of the update of the first week of the final project. The main goal of the project is to provide a better classification and identifying cancer in people, and the first week's update is to implement k-means clustering in some form. In order to do this, the initial stages were the same as in lab 10. We had to set up the data we used here was the NCI database, which was used in lab 10, and we implemented the same steps as in lab 10, executing the code like check py and parse file id request method. This is basically used to get the file ids and case ids, the extra information which we need. And then we made a little change in the gen miRNA matrix. Here we added a label column. Initially the label column was given the same value as the sample type. Next, based on the primary site, that is lung, stomach, and etc., we gave a unique integer to each one of them. This we did using the dictionary. So every time we received a primary site, we put in the dictionary, and next time we receive it, we try to fetch the value from the dictionary if it is there. If not, we add it to the dictionary, giving it an unique value. After running this, we get the miRNA matrix.csv, which I've already done. I'll go ahead and show it. So the last column you can see is the labels that are generated, and based on the primary site here, each one of them will have a unique integer, and this goes up to 27. um, this is a basis for us to form the k-means to implement the k-means clustering. In the next part of the video, we'll be showing how we have implemented k-means. Before implementing k-means, we deploy a method called PCA, because the data that is generated in my miRNA matrix is it includes a lot of dimension, and we reduce that using PCA and then apply k-means and form the cluster. And using that, we then try to correlate the information, that is the clusters which are formed, the file IDs, what do they correspond to, what ethnicity, what sex do they correspond to, and then do the next step.
Now in this part of the video, for the generated matrix, first we will normalize the data. Normalization of the data is very important to bring down each dimension to the same scale, because here you can see in the data, some of the dimensions are in thousands and some of the dimensions are in zeros and ones. So normalization is very important. And then we'll do PCA, principal component analysis, and then we will do elbow method to find out the best K. And then at the final, we'll implement k-means clustering. Now, first, we will import the necessary libraries, and then we will load the generated matrix into the Panda data frames, and we'll create Y label, X label, and the file IDs. So here you can see that this is a sample of the generated data. These are the these are the rows, and these are the columns. And now first we will normalize our data using the min-max scalar function, and then apply principal component analysis. Here you can see that I have given the n component as 500, and we'll be having till 0 to 499 dimensions. And for the 500 dimensions that we have created, we'll find out the variances. These are the variances I have found out. And then we have seen what is the ratio of the original data represented. So from the original data, this principal component analysis generated matrix will represent 83% of the data, which is quite good. And now we will find the best K using the elbow method. Here you can see in the graph that 11 is the best K, to be best value of K to be clustered. And we have clustered, and now we have obtained the labels in each cluster. And you can see here that we have generated 11 clusters, with each cluster having several file IDs, such as cluster 1 has some 4,871 clusters. And for the first part of this project, we have reduced the dimensions of the data and clustered the data into 11 clusters. And in the next demos, we will try to find out some correlations of these clusters and give some meaningful results. Thank you.